So what I'm going to show you guys today is how to write a piecewise function. And if I was given the parent function of the absolute value of x, so f of x equals the absolute value of x, okay, usually I would write that as two different things where I have a positive x and a negative x. My positive x would be x is greater than or equal to 0, and my negative x would be whatever's left over. So in this case, I want x is less than 0. Okay, so again, this is my parent absolute value function, and this is an example of how to write a piecewise function. But for us, we'll have a little bit more complex. So I don't know, let's say I had f of x equals the absolute value of x plus 3. Not too complex. But what I do is I again split it into two things, and that was a horrible bracket, but whatever. And I have x plus 3, then negative x plus 3, and again I want when x is greater than or equal to, and in this case I want when this is equal to 0. So I'm going to look at what x value makes x plus 3 0. In this case it's going to be negative 3. And then I take whatever's left over. So x is less than negative 3. Okay, so then one more example of this would be, let's say I had g of x equals 3x plus 1 over x plus 1. Okay, this will be something more on the lines of what you would see. I just wanted to give you little breakdowns on how to do this. So again, I still do the same exact setup as I did up here. I want to write it into two different functions. So I would have 3x plus 1 over x plus 1 when x is greater than or equal to negative 1. Again, I'm taking, actually from my absolute value, I'm taking when this equals 0 and it's at negative 1. And then I would have negative and then 3x plus 1 over x plus 1 for whenever x is less than negative 1. So if you notice now though, I have two x plus 1s here on both equations that can cancel out. So I'm going to go ahead and do that. And from this part I would be left with a piecewise function where I have a positive 3 for when x is greater than or equal to negative 1, and I would have negative 3 for when x is less than negative 1. Okay, and this helps me because let's say that this problem had asked me to find the limit as g of x approaches negative 1. Okay, I don't know what that value is because remember that if I plug negative 1 into this function, I can't. I'm going to be dividing by 0. So breaking it into two different parts is going to help me understand what does this function actually look like. So if I were to graph this, I'm going to go ahead and flip this over. If I were to graph this, I know that, forgot already. I know that it's 3 for all values greater than or equal to negative 1, and so let's see. I know that all values greater than or equal to negative 1, I have that this is 3, so, and it's greater than or equal to. So I have something that looks like this. And then I also had negative 3 for values less than negative 1. So values less than negative 1, I am negative 3. 1, 2, 3. And again, I'm an open circle because it was just a less than symbol. Okay. So if my equation had asked me find the limit of g of x, okay, as x goes to negative 1, and again remember g of x was 3 absolute value of x plus 1 over x plus 1, okay, if I'm trying to find the limit of this function here, g of x, as x goes to -1, notice my left-hand limit is approaching -3, or I was -3. And then my right-hand limit, where am I at? My right-hand limit is approaching +3. Okay, so if I look at this, the limit, let's go ahead and say the limit as x approaches -1 from the left of g of x equals -3, and the limit as x approaches -1 from the right is +3. And remember, in class today I said that these limits from the left and right hand side have to equal each other in order for you to have a limit at that point, x is -1, or any point that you're talking about. In this case, they are not equal, so I would say does not exist. Okay, again, it's just an easy way for us to decide or look at how I can graph this function and understand what is it talking about and what is it telling me, and this is what it's telling me in this case. Okay.